So let's practice this idea of converting things around. So it wants to know how many moles of water would be formed. So then this is the product, and we're still talking about using that reaction at the top. If you have this many moles of hydrogen gas. So I'm going to zoom it in a little. This is the same reaction that we've been talking about on this whole page. It's at the top here. So it's 2 hydrogens, 1 oxygen to 2 waters. So again, it's 2 hydrogens plus 1 oxygen goes to 2 waters. That's what we're using for these. So we have 3.50 moles of H2. And then we have moles of H2 into moles of water. So I can say 2 and 2. That just means I'm going to put a little extra in my calculator though. But you can do it. You'll get the same answer as me, and I'm saying 1 to 1 because you can simplify it. So the answer is 3.50 moles of water. So this is the theoretical yield. Again, that's the perfect yield. We're not really going to make it, but you should get kind of close. Now, I'm going to pause, and you go ahead and work the next 2. Notice I'm already always giving the numbers off the chart. Want to make sure you're getting the process correct. I'm assuming you can add up the numbers from the chart on your own. Okay. So we've got 3.50 moles of hydrogen gas. So I'm going to go from moles of hydrogen gas to moles of oxygen, and then I'm going to go from moles of oxygen, and it wants to know grams. So like I probably should have run over the side question mark, grams of oxygen. So I'm going to go to grams of oxygen. I get the numbers in the middle from the reaction. You notice that there were 2 hydrogens to 1 oxygen. And then this comes from the periodic chart. There are 32 and 1 mole. When I do the math on that, I'm going to say 32 times 3.5 divided by 2. You can do 3.5 divided by 2 times 32. Or you can put all the ones in if you want to put the ones in too. But you are going to get this answer. Notice how many sig figs. It's because I should have put 32.00 on this one. The sig figs are because it starts with 3.50, which is 3 sig figs. And then the next one, so I've got 10.0 grams of oxygen. Then I have 32.00 grams of oxygen and 1 mole of oxygen. And again, you can wait to put the numbers in. A lot of times I do. It's asking about grams of water. And so we need to get to the water before we turn into grams. I can't just go like that. You can't do it that way. You have to use your moles to get between them. So moles of water. And so I've got, from the reaction up here, 2 waters to 1 oxygen. Again, you can put all the units in first. And so I need this 18.02 and 1 mole. So when you're doing the math, you're going to say, 10 times 2 times 18 divided by 32, or you can do it in any other order. Do note that I am putting all of these to grams of oxygen. Grams of oxygen. Notice I'm not just saying grams when I'm saying grams of who, because I'm switching between the who's. Here, 11.3, notice that that's 3 sig figs because I am starting with 3 sig figs. Remember when you multiply and divide that sig figs are based on the number with the least number of significant figures. You don't consider molar ratios for this because they are exact. So the 2 and the 1 in this equation is considered exact. Then you also don't usually have to consider the molar mass, because molar masses usually go out to far more decimal places than the amount that your scale is going to be able to weigh with. So most of the time, but not all the time, you can just look at that first number that you started all of your multiplying and dividing with in these sorts of problems, and you can use that as your number of sig figs. Again, it's not perfect, but it's a good rule of thumb.